Okay, so this is the very classic questions of the DP on grid. So what's the question? This is the lead code number 62 unique paths. So what's the given in the question? We are given an M cross and grid, and what's in it? A robot which is start at the top of the left cell, which is 0, 0, and wants to reach the bottom right cell, which is m-1, n-1. And what are the movements robot can take? It can either move in the right direction or the down direction. So like let's say it is at any cell I comma j, so it is move in the right, means it goes to I comma j plus 1, or either in the down condition, down direction, means I plus 1 comma j. So these are the basic given constraint on this robot, that only two movements are possible for this robot. Since like at every position we are making a choice, like between two moves, either in this or either in this. So like we can think of this as a recursive solution, because whenever if we have a multiple choices at any given index, so this gives us intuition about thinking in the recursive direction. Okay, so go for this. So we have to try all of the possible path there, and count like how many reach the destination, given in this test case as equal m equal to 3, n equal to 7, and for second example of say this. Okay, so let's say this is the short case there, so I've explained it in this. So this is m is equal to 3 and n equal to 2. So if I have to draw that part here, okay, let's say, so this is m is equal to 3 there, and this is n is equal to 2 there, and we have to start from here, and we have to destination, this is our destination, this is our starting point. So how we can do this, how this is given in the test case here. Okay, so how we reach here, since our starting is at 0, 0 there. Okay, wait a second, 0, 0 there, and our end is at it is a 2, 0 there. Okay, so how we do this? So what are the possible, we know, since this is a very short test case there, so we can directly write what our answer is. It is when we go to the right part, then down part, then down part. Okay, what other possible condition? When we go to down part, then right part, then down part. Okay, what's other condition? Go part down, then right. So there are only the three possible cases there, in which it has to traverse from 0 to 0, 0, 0 to 2, 0. Okay, we can also consult about any other test case there. So first of all, since we have to say this is our recursive, so we define a function, let's say f of ij. So what basically means of this is nothing but the number of path. We can I can write also. So this is number of path from, I can say here, let's write it here, this is I comma j cell to 0, 0. So this is the definition of f of I comma j. Okay, this is basically the definition of f of I comma j. And what is our final answer? We have to simply return this. Wait a second. Okay, so here it is we have to reach to end of the our array there. Okay, so don't confuse it, it is given in the question. Actually it takes it m is as a row or n is equal to column, so don't confuse with this. Let's say I will also again, let's say I write this here, this is m minus 1, this is m or n is nothing but, in the question it is generally it take it as a row there, and n it take as column. But personally whenever I am do coding there, so I am taking that configuration, so in I'm generally using row as n, and so it doesn't matter what are the name of the variable. So let's go to our, so we see this is the definition for our recursive. So now we try our brute force there. So we say one thing there, to reach C cell, let's say we have to reach the cell number I comma j. So how we reaching to this cell there. So there are the two cases there, either we have to come from the left cell or either we have to come from the let's say, first of all, since this is a memorization version, so generally we have to go from this upper to, this is a top down approach there, so we have to start from the end. It doesn't matter, we have to starting from the ending or we can starting from the this to reach to this, it doesn't matter. Basically we have to cover this grid there. Okay, so in this memorization version, let's say we have to talk about this how we brute force. So I can say I have to do this like if we have to reach cell number I comma j, so how we can say, so we can come either from the top or the either from the left. And what is the top and left? It is nothing but it is I minus 1 comma j. Okay, and what is meaning of the left? This is I comma j minus 1. I think you understand it very well. Okay, so let's say this is our I comma j. So what is in its so like if we have to come from the top, if we have to come to this part, like we have to go for this part to since in the question it is given as we have to move only in the two direction. Let's say what is given in the question there, so we should go for the bottom or right corner. So either it move in this bottom part or either it is move in this right part, but let's say we have to start from this, since we have to go for memorization version, so we have to start from this, so its direction become the upper and the left. So that's why I use there I minus 1 j or ij minus 1. So if this is our I comma j, let's say this is our I comma j there, so I minus 1 becomes this and ij minus 1 becomes this. Okay, so when it comes from the, when it goes to the left, so it is this, and when it goes to the, so it is this part. Okay, so like we can say one thing there. Okay, and since we define our f of I comma j there also, so we can say f of I comma j, it is nothing but f of I minus 1 j there plus f of I comma j minus 1. So this is the definition of our, and what is our base case here? So base case is if we have to reach to upper of index, means f of 0 comma 0, so that is our base case there. So what is the way here? So there's only one way here, that's why I have to write only is equal to 1. Okay, so let's say I have to go for a big test case there. To draw for the three chroma, see there is, I have to draw for the explain the recursive tree part. So for it I have to draw 3 comma 3 grid there. So here n is equal to 3 and m is equal to also 3 there. Okay, so how it is going, so this is our so we have to start from this and we have to reach to this there. Okay, so if we have to call for the f of 2 comma 2, so what it means, so if you have to starting from this, so what are the possible ways to go there? F of 1 comma 2 means either it is go to this part, or either f of 2 comma 1 means either it is go to left part. So that's why I have to write either it is go to the top or either it is go to the left part. Okay, again let's say if it reaches to f of 1 comma 2 there, means it reaches to this cell there. So what is the possible further directions to there? So either it is goes to 0 comma 2 there, or either it is goes to the 1 comma 1 there. Similarly, if it reaches to 2 comma 1 there, so here what are the possible movements there? Wait a second there. Yeah. So either it is goes to the 1 comma 1 there, or either it is goes to the 2 comma 0 there. Okay, like after when it reaches to the 0 comma 2, since okay, so since when it reaches to the 0 comma 2 there, means it is goes to the here. So what are the possible cases here? since there's a not possible cases of going upward because it is going outward of the grid there, so that's why the only possible cases is it goes to the 0 comma 1. Okay, and for f of comma 1 actually okay, this is for the explaining part there, but I skip this part here. Okay, so what are the only case possible here when it is goes to the f of 0 comma 1 over here. Okay, and when it is start from the f of 1 comma there, either it is goes to the upper part means 0 comma 1, or either its left part mean 1 comma 0. Okay, so this is the same condition here, so we don't like we already seen in our the DP questions there, so this is denoting a overlapping sub problems there. So what are the solution we have to do for this? There's no need to do again for this test cases again for this sub problem. So basically how to avoid this recomputation there, we simply store this. So for the storing vector we use the DP vector, that's why we should go for the DP. Otherwise if see one thing there, after some time I've explained again you like how I why I to think about the DP part. Okay, so like we see one thing, like we know very well how this recursive tree is working well there. Okay, we see one thing that this appears multiple times here, so this nothing but the overlapping sub problem. Okay, now go for the brute force there. So what's the brute force here? So this is our brute force there, so we have to simply return the m-1 comma n-1. This is our main function, and what is the definition of our this solve function here? So this is a definition of solve function is, first of all we write to this like base cases here. If I reached to upper part means row 0 and column 0, so this is our desired position, so that's why what are the possible ways to return here? So only one way, that's why return 1. If we go outside the grid, so how it is possible, how number of ways to reach there? So there's no way possible, that's why return 0. Okay, so by this we have to handle all of the edge cases there. Okay, and there's a two cases when we call for when we are stand at the I comma 0, so row -1 means we go to this, we are calling for this part, and again column -1 means when we calling to this part means like a left part or top part or left part there. Okay, so and simply return the what are the summation of this. So let's because I already explained you why f of I become this, so that's why to write this. So this is the brute force, but see since if you have to see what are the constraint given in the question there, so the constraint is m or n are reaching to the 100 there. So whenever we are stand at the I comma j there, so what are the possible ways to go from that cell there? So it is goes to the upper left part, then it is goes to the upper left part, and then similarly same for the all of the cell two of the grid there. Okay, so how many of the number of cell there? There is a m plus n1, and each cell has a two options there, so that's why the time complexity is become there. I'm using comment there also, so it is 2 okay, so this is our time complexity is become this, and what is our space complexity is? Space complexity is nothing but the m plus n there, because we use extra vector there, which is, so this is space complexities of the whole of the vector. Here you see this is exponential time complexity, so it gives us TLE, so that's why we should go for most optimized way. So so what we called is this optimized way, this is nothing but the memoized version. So I'm already write the code for the memoized version there. So let's copy to the editor part, and now see what it is. So this is nothing, this is also already easy there. So first of all I initialize the DP vector here, I have to call for the solve function there, This is the base case. I already explained in the brute force. This is again the to handle the extra edge cases there, so that it doesn't escape to outside the grid there. This is in case it find any stored solution there. There's a two condition there, from top and from left there, and we have to store that in row column and simply return this. So this is our memoized version there. And what is the time complexity for this? So time complexity is m into n there, okay. And what is its space complexity is nothing but the m into n, but there's also a recursive I can say recursive stack space complexity also. So that is, so this is our memo version. This is and previously we also discussed the brute force version. Now okay, so this is a question. One thing about this question, like you see this question very well on the internet, but there is very mathematical like I can say, I can give you the hint of about like you can say about the combinatorics in this field. Like you can go and search, you can also think about is any kind of the mathematical approach to this question can be exist or not. So before it, you can also do this by DP. In my further videos, I can also I also do this question, this unique paths question, by using the mathematical approach, in which I use simple like the permutation combination part there. So that I do in my further coming videos. So thank you for this.